Hello friends, welcome to my channel Study Corner. So today we will discuss about the laws of motion. Sir Isaac Newton. Here the kinematics. What is the meaning of kinematics? Kinematics means the rest and motion. It says the effect like a body moves, body changes the speed, body covers some distance and a body accelerated or not. But why these things happens? We will discuss why the motion happens, why motion is stopped, and what is the cause of the motion, which is included in the dynamics. It is a part of a classical mechanics, also called Newtonian mechanics, and formulated in the late 17th century. It is formulated in the late 17th century, 1642 to 1727. In this chapter, we see some pulley, some inclined plane, chain on table like these examples. Large number of principles and results may be derived from the Newton's laws, but first we will discuss on some forces. About the force. Here, force is a vector quantity. Its unit is a Newton, which is SI unit, and for the CGS, it is dyne. Now let's take an example for a box. Let's take a box. A box has a speed u. Here this box has a speed u. If we apply some force, then after moving at some distance, its speed is say v. So there is a change in state. First of all, box is here. After we apply the force, the box is at this distance. So there is some change in the state. So the question is, why box is moving? Because there is some force on the box. Here we apply some force. Now force is that cause which changes the state of the box. Force is that cause which changes the state of the box. In Newton's law of motion, we only discuss on force. Now you will understand why the force is important for the motion. Let's discuss on the gravitational force. Gravitational force. What is gravitational force? It's a weight. Suppose mass m here, mass m, then earth is attract this mass towards the center of earth, Now weight is always act towards the center of earth. Remember, weight is always attract towards the center of earth. Suppose the mass is here, then it is also attracts towards the center of earth. Now the gravitational force is equals to G m1 m2 upon r square. Suppose we have mass m1 and m2 and the distance between them is r, then the gravitational force is equals to G m1 m2 upon r square. Here 1 kgf is equals to 10 Newton and 9.8 Newton approximate. So let's understand the normal reaction force, which is represented by the capital N. Normal force. It is a perpendicular. Let's see. Normal force is perpendicular to surface. Normal force is a perpendicular to surface or perpendicular to point of a contact. Now let's take an example. Suppose the mass of the object is m. The weight force is applied towards the downward. So W is equals to m into g. So is mass falling downward or not? The question is, mass here, this mass is falling downward or not? So answer is no, because some force is also act towards an upward direction, which is called a normal force. Let's understand in detail. If mass of the object is m, here the mass of the object is m, it is on the surface, here this is the surface, and it is at a rest position. We say that the box is at a rest position. Now box will exert a downward weight force on the surface. Here as we see, weight force is equals to mg, which is in the downward direction. Now every object with a mass m has a weight force on it. Every object with a mass m has a weight force on it. Due to the force of the gravity, it is going to pull it towards the earth. Why it is falling downward? Because due to the gravity, it's going to pull it towards the earth. Now let's understand. The surface must be exerting an upward force. Because we see a box is at a rest position. So because right now the box is at a rest position, and in the state of the equilibrium, so that means the downward force must be cancelled. And equal and opposite upward force, and this force is known as the normal reaction force. Let's take another example of an inclined plane. Suppose mass m is here, then the normal force is towards in this direction. Normal force is towards the perpendicular to inclined plane. Let's see. If mass m has a normal reaction perpendicular to inclined plane surface, here the normal force is applied by the surface on mass m. In this case, the normal force is applied by the surface on mass m. Similarly, mass m is also applied a normal force on the surface, but they don't cancel each other. Because both normal forces are different. Let's see another force, which is tension force. There is a tension force in string, rod and chain. We see some example based on the tension force in this chapter. Now understand, the T is always away from the point. And if string is changed, then T is changed. Let's understand. A mass m is suspended by a rope from the ceiling. Here mass m is suspended by the rope from the ceiling. The force acting on the object of a mass m is mg. So the question is this object is falling or not? So the answer is not, because some force acting upward direction, which is called the tension force. The object is not falling. Because our object is suspended by a rope from ceiling. Now let's take another example, mass m1 and m2. If we apply force F in this direction, if we apply the force in this direction, then mass m1 and m2 has tension force for m2 is away from m2. Here tension force m2 is away from m2, and for m1 the tension for m1 is away from m1. As we see, both the tension are different. As we say that the string change, the tension is change. We see here the tension is same, and here for this the tension is different. For this string the tension is same, and if we change the string the tension must be changed. In next video we will discuss on Aristotle fallacy and Galileo's experiment. Thanks for the watching.